Okay, so we'll have a quick introduction. We'll then look at the status quo, the innovation core, application example, and the way forward. So skipping through the introduction, just to give some background, I'm not sure how many of you are familiar with MPA-MOT. MPA-MOT emerged as the acquisition by MPA of Mott MacDonald Africa. So at the moment, this leaves us as the largest 100% Black women-owned and led civil engineering and development consultancy firm in South Africa, and we still have very close ties to Mott MacDonald globally, which gives us a fantastic inroads into the technology, etc., that is being developed and applied on some mega projects around the world. So let's take a look at the status quo. Construction has always been seen as the innovation laggard, and when one looks at the supporting statistics, it's very clear that construction has not performed nearly as well as other industries in terms of adopting or applying technology. If we look at this extract from a recent McKinsey report, annual productivity growth over the past 20 years was only a third of total economy averages. Risk aversion and fragmentation, as well as the difficulties in attracting digital talents, have slowed down innovation, and digitalization is lower than in nearly any other industry. So this is quite a telling starting point from an engineering perspective, in the sense that industries such as agriculture and various others have raced ahead of the built environment, and it gives us a really good baseline to now start innovating very quickly to catch up. I think the other important thing here, and I think I saw a question in the pop-up box a little earlier, was profitability is low, and this is at a global level. This is not just local, at around 5% of earnings before interest and tax. So despite high risks and many insolvencies, customer satisfaction is hampered by regular time and budget overruns and lengthy claims procedures. I think this ties into a number of things that have been touched on by the other speakers earlier on, both from an insurance point of view and in terms of the way projects are delivered. Now, this slide I know is particularly busy and you may not be able to see it in great detail. So I'm just going to run through this briefly, and it's really a look at today's construction ecosystem from a new build perspective. And what it highlights is some of the key inefficiencies in the current status quo of the way projects are delivered. I think one of the most important aspects is that it's highly project-based. And I think there's a differentiation here that needs to be made. There will always be mega projects that are incredibly unique. I think around some of the dam projects we saw earlier and some of the other major mega projects. But each project currently is designed from scratch effectively. I mean, we may have CAD standards and BIM libraries, etc. But the uniqueness of each design is actually a fairly large hindrance to optimization and efficiency. If one looks at the industry and the way projects are delivered, it tends to be localized and highly fragmented. And the lack of integration of the various components in the supply chain actually contribute to hindering innovation and the digitalization. And that covers materials manufacturing, component manufacturing, and the actual logistics chain through to the distribution to site. Then one looks at the actual construction process on site. And construction is typically performed by generalists on site in what's typically a less than ideal environment from a manufacturing point of view. If one compares it to the manufacture of aerospace components, for instance, that have a nice, warm, well-lit factory with lots of CNC machines churning out hundreds of identical components. The manual nature of the built environment is the complete opposite of that. And the project uniqueness creates a number of challenges from an efficiency point of view. So there's high levels of rework, there's significant delays to projects, and any minor changes have a knock-on effect within the overall project delivery cycle. So the highly bespoke nature of construction projects effectively is one of the hindrances, one of the main hindrances to the sort of acceleration of innovation in the industry. So let's flip over to the innovation core, as I like to call it, and look at some of the supporting strategies and technologies. Now, a number of these we've actually touched on already while we have looked at the other three presentations prior to this. So I really like some of the aspects from the Aon presentation around the digitalization of the entire process. And this goes back to the first key strategy, is digital by default. is no longer optional. I think from a relevance perspective, particularly within the built environment, there are huge innovations in the surrounding technologies that the construction industry has yet to take advantage of. And areas where we're seeing a slow uptake now, and where I think a lot of promise and potential lies, is around the computational and parametric design aspects. So from a computational design aspect, you can create far better optimization in design solutions by being able to run thousands of iterations. And the approach using a parametric design allows one to iterate that same design process by rather using a logic approach rather than redesigning it from scratch. So you'll see the adoption of that with tools like Dynamo in Revit, which is very much focused on delivering that parametric design approach. Then the automation side, AI and machine learning offer untapped potential. And we're starting to see a huge amount of data becoming available from this. And the amount of AI and machine learning opportunities around traffic monitoring, transport planning, and pretty much anything else you can think of, really. As long as you can feed the algorithm data, you can start to extract value from it. And I think this is where companies need to look at, particularly from an engineering point of view. How many times have we sort of battled through the same spreadsheet to come to a set of answers, when effectively, with a little bit of time and resource investment, you could create not only an AI, but a machine learning foundation that's able to analyze and adapt on an iterative basis rather than allowing you starting from scratch. And then I think resilience is one of the key strategies that's becoming more and more to the fore. While the world's been sort of in lockdown, what we've seen is that there's been some quite significant changes around the world from an environmental perspective. And what it's highlighted is that there's a growing need for resilience, both from a climate and a societal point of view, in terms of the value that infrastructure delivers to communities. So resilience, I think, is a key element that's starting to come through in the way that we design and the way that we deliver services. And that resilience is well suited to using big data, AI, machine learning, and various other strategies to help build that into our designs. Then cutting carbon to cut costs is another area that's becoming more to the fore. Previously, if you mentioned carbon 15 years ago, you were the odd one out standing in the corner of the room. But cutting carbon now has very clear linkages to cutting costs. And with most countries having some sort of carbon program now, this is becoming a very mainstream concept. And again, it's an idea where technology really provides multiple platforms. We work closely with Mott MacDonald on what they call their carbon portal, which allows you to input your design effectively, and based on an underlying computational engine, it actually spits out carbon values. So you can actually option different outcomes based on not only the capital cost, but the carbon cost as well, which is a way in a number of particularly European countries seem to be moving. And I think this is something that we need to definitely give cognizance to in an engineering design perspective locally as well. Then the enhanced collaboration. I mean, we've seen collaboration across the board. I think the built environment, again, has been fairly slow on the uptake. I mean, BIM's been around for almost 35 years now, and there's still only a 75 to 80% penetration. I think if one looks at microwave ovens, that had about a 10-year penetration to reach that sort of percentage. Technology brings better ways to visualize projects. And this is where we're able to make big differences, because visualizing projects allows people and communities to better understand projects. So one of the key strategies is, from an engagement point of view, is to apply technology to bring projects to life. While engineers like an overly complicated looking drawing to show what good engineers they are, most people would just like to see a pretty picture of what it's actually going to look like and what benefits it brings. So visualization is becoming more and more important to projects, and we're seeing a number of AR platforms, VR platforms, and even web-based visualizations. Then materials, one of my favorite topics. Materials, we're seeing some huge changes in materials. I think the previous speaker alluded to some of the nanotechnologies that are being applied. in roads. And I mean, from a materials point of view, we're seeing it right across the built environment, where previously insulation that was used on the Mars rover many years ago is now being used as drywall insulation in cold countries. So that filter through of new materials is starting to have an impact on the way we design. And I think it's important that we encourage people to stay up to date on what technology is available. Don't go back and specify. I think we've all had the experience of finding drawings that specify some product that's actually no longer even manufactured. And it's because it's just been copied and pasted from drawings from the past. I think the innovation potential is there for us to, particularly as young engineers, to revitalize that materials application and drive the process of looking at new ways of delivering. And in today's project engineers, more accountability and responsibility across a broader scope. This is definitely something that from a local context, I think is even more critical, particularly against the backdrop of super discounted fees and particularly the amount of competition in the market and a limited pool of work. So any means that technology can help you manage the responsibility and the risk associated with the engineering work that you do and the responsibility that you take as an engineer is something to be adopted with open arms. And then I think something we tend to forget is the client experience remains pivotal. So at the end of the day, we aren't much without customers, and our client experience from an innovation point of view, again, there are a number of strategic options available to drive this, where we can enhance the client experience through the implication of going back to the Aon presentation, through apps and engagement and portals and online presence, etc. I think these are particularly outside of the traditional engineering scope, but they provide a lot of value in that overall client experience point of view. And then last but definitely not least is what is the societal benefit? I think that's a question we need to ask ourselves as engineers on a regular basis, is what benefit does this bring to society? I think often the total cost of ownership is overlooked from a design perspective, and it's more about the upfront capital cost and the design process, the approvals process, and come completion, that project is done, dusted, and we move on. But at the end of the day, it's society as a whole that actually picks up that project and has to live with it for the next 50, 100, 150 years. So from a design point of view, is what societal benefit do we bring? So the construction ecosystem of the future, here we're going to look at what we'd like to see. And I think we definitely look at a more consolidated value chain, entire designs more specific to components from a standardized suite. I think the real options here are designed for manufacturing and off-site manufacturing, where there's much more control and a much more modularized delivery system. It also feeds into the logistics capabilities, and I think we've seen this with companies like Takealot, etc., where an entire new sort of subsector of logistics has grown around online shopping, which has even been further accelerated by COVID. And then the inclusion of autonomous machinery. I mean, we're already seeing a lot of earth-moving equipment that pretty much does itself based on your design, and enhanced analytics, embedded analytics. So these are all the nice to haves that we should be targeting from an innovation perspective. Now, time-wise, I'd love to spend a lot more time drilling down into this, but unfortunately we have to move on. So just to give you some idea from a collaboration point of view, this is the current Autodesk BIM 360 partner integration, and this gives you some idea of the global move towards integration. If one looks at the sort of 100+ companies that are now embedded and able to integrate into BIM 360, you can see that the shift in innovation is rapidly picking up pace, with all these innovative startups and smaller firms being able to tap into the BIM 360 platform. And then just a couple of examples that always inspired me from a computational design point of view and innovation. This is a company called MX3D in the Netherlands that set out to 3D print a very organic looking bridge that would almost be impossible to build out of conventional steel, but using some modified welding robots from ABB and various Autodesk design tools, they're able to effectively print this 3D bridge out of metal. It's fully functional, you can walk over it. And if one looks at those shapes and curves, etc., you realize that this wouldn't have been possible using conventional design methods. And this is where the innovation is starting to head, is that there are tools that can actually break the mold of traditional engineering. And this is where we need to be looking to adopt these tools and apply them. Another area that quite inspires me is the self-assembly or materials that are able to be pre-programmed with shapes. Imagine your rebar that bends itself on site when it arrives. It can travel flat packed, and then once it's activated with a certain electrical current, can change its shape. So these are mainly based on plastic polymers at the moment, and most of the research is coming out of MIT, but it really does provide a glimpse into the future of building materials. And then just moving on to a quick application example. This was the project that won the CESA awards this year. And some of the aspects that we applied on this project, I think very much tie into what I've mentioned. So just from an overview here are the quick stats on the project. So it was a sizable project. I think probably the most challenging portion of this project was the fact that it was a 20-month construction period for an entire sports complex. And we really had to sort of pull out all the stops in terms of leveraging innovation and digital delivery to get this done. So that was the end result. It actually worked. And the entire approach was a digital by default, technology plan driven and standard tools delivered approach, where not only from a design point of view, but from an interaction with a contractor and a client input perspective, there was as much digitization as possible, which not only enhanced the initial delivery, but also created a much greater pool of legacy information from an operational perspective. This was the swimming pool roof, which I think was probably one of the most challenging aspects of the project. So it's a curve in two directions. Now this, from a parametric and design point of view, we looked at Grasshopper scripts to drive the initial geometry calculations that fed into the analysis model, that went back to the architect's Revit model, and then the Grasshopper geometry conversions between concrete and steel options. And that then resulted into the detailed analysis models, which finally went out into the setting out CAD drawings. Now, given that this roof changed shape, size, weight, and cost probably 50 times, to have done this as a traditional design method would have been virtually impossible within the timeframes allowable. But using the technology available, we were able to iterate these designs literally within a day and look at the different options with the contractor, with the client, and actually come up with solutions that worked. So this is direct application of that innovation. So as we draw to the close here, I'd just like to touch on a couple of technologies and innovation applied. I think some of the key aspects that we used were using digital from a robust project controls point of view. And then there was a digital approach to a very aggressive change control point of view, given the short time frames and the hundreds of decisions being made on a daily basis. Without any sort of digital platform, this would have been, again, almost impossible to manage. So Power BI played an important role, and a number of web apps. Then dedicated document control with a SharePoint backend, again, helped from a digitalization point of view. The unified information platform, again, allowed everyone to have a common sight of the most current data, and digital delivery allowed for the information to be used in a fairly graphical manner. And given that we're working with a Chinese contractor, this helped overcome a number of language barriers as well in being able to dive into the model in Navisworks or in BIM 360 and actually iron out some of the construction practicalities. So the way forward, defining trends in innovation engineering. These are some of the key takeaways that I've put up here. And I think autonomy everywhere, artificial intelligence likely to define the coming decade, and that's been highlighted previously. So we have the opportunity to automate. So I think from an engineering point of view, it's critical that we strategically automate. There's no point in doing work hundreds of times that can be automated. Bigger, better data, the more data you collect, the more opportunities it provides from both an analysis point of view and an opening opportunities perspective. Plug and play, the drive for enhanced standardization. This goes back to product manufacturers, material suppliers, etc., where enhanced standardization will ease the design. And the growing complexity, and as the built environment shifts from fragmented development, we again need to manage that complexity using digital tools. And then old industries are new again. The reinvention of traditional businesses is a new norm. I mean, we've seen this with Tesla. You know, car manufacturing's been around for over 100 years, but Tesla very much reinvented that. We're seeing this with SpaceX, where the traditional NASA and Arianespace are getting their asses kicked by new startups. And then the resilient system, refocus on climate, carbon, social, and resilience in design. So I think those are the key takeaways. And that brings us to the end of the presentation. And if anyone is keeping up, you can do a little bit of homework or some bedtime reading. Have a look at some of these if you have an interest in materials or any of the other applications of biomimicry in design, etc. And that's it from me. Thank you very much.